Hello everyone, welcome back to my channel. In this video we are going to see the chapter Relations and Functions, and I'm going to explain all the topics. Now I'm going to make this video into two parts, and in this particular part I'm going to explain relations and their types. This is a topic in grade 12 mathematics, and in the next video I will be explaining the second part of the chapter, that is functions. So now let's begin with the first topic, that is relations. So what do you mean by a relation? When we say relation, it means if there is a connection between two sets and we want to establish a relationship between them, then we can use the concept of relation. Now, last year you would have studied about Cartesian product, and you know, if there are two sets A and B, let's say A is 1, 2, 3, 4, and let's say B is 5, 6, 7. Now, if I am writing the Cartesian product of A and B, which is denoted by A cross B, what will happen is each element of the first set will be matched with every element of the second set. So 1 will be matched with 5, 6 and 7. 2 will be matched with 5, 6 and 7. 3 will be matched with 5, 6 and 7, and 4 will also be matched with 5, 6 and 7. So if you want to connect all the elements of two sets, it is known as Cartesian product, and you know the elements of the Cartesian product will be in the form of ordered pairs like 1, 5, 1, 6, 1, 7, like this. It will be in brackets and the elements will be separated by a comma, and this is known as an ordered pair. This is something which you have learnt in grade 11. Now, relation means if we are imposing a particular condition. Maybe let's say I am making a condition that like for example, if I'm writing a relation R and I am writing the elements of the relation must be of the type x comma y, that means you're saying that it is an ordered pair. Now the condition I'm going to write by putting a colon, and what is my condition? My condition is y is equal to x plus 4. This is my condition. So now what will happen is the set containing all the elements connected with each other is the Cartesian product. Now the relation that we have created is a part of the Cartesian product. It is a subset of the Cartesian product. So first of all, what you need to understand is a relation is a subset of the Cartesian product. That means the elements of the relation will always belong to the Cartesian product of the two sets. Now the difference is, in the relation you will have only the elements which satisfy this condition. That means what we are saying is the y element, that means the image, or you can say the second element, should be 4 times greater than it should be x plus 4. It should be greater than x by 4. So you know that this element is known as the image and this element is known as the pre-image, and the x values are obtained from the domain of the relation and the y values are obtained from the range or from the codomain of the relation. So this is known as the image. So now in the relation, for this particular example, only the elements 1, 5, 2, 6 and 3, 7 will belong. So now what about 4? According to the Cartesian product, there is no element called 8 in this set. And you know, if x is 4, then y value must be 8. But 8 does not belong to the set B. So as a result, the elements in the relation will not have 4 as the pre-image for any of the ordered pairs. So this is the relation, and all the elements in the relation belong to the Cartesian product. So as a result, the relation is a subset of the Cartesian product A cross B. So this is very important, and it can even be equal to the Cartesian product. Let's say if we're not specifying any condition, or if we're specifying a condition which is satisfied by all the ordered pairs in the Cartesian product, then the relation will be equal to the Cartesian product. So this condition you need to know. This is the basic condition for any kind of relation. Now let us learn the domain, range and codomain of a relation. Again, this is something which you have already learnt in grade 11, but I am just giving a brief recap. So the set of all the first elements in the relation is known as the domain. So the domain, all the x values are known the set containing all the x values are known as the domain. So in this case, if you see, the x values are from the set A. So A is known as the domain of the relation R. And all the y values, that means all the second elements, are from the set B. So this set is known as the range of the relation. Now let's say in this set, instead of having only 5, 6 and 7, I am going to add another element, that is 9. Now you know, if 9 should be included in the relation, then the x value must be 5, because 5 plus 4 is 9. So now there is no element called 5 in the domain. The domain is 1, 2, 3, 4. So unless there is a number 5 in the domain, you cannot create any ordered pair satisfying the relation with the element 9. So as a result, this set B, it is having some element which is not belonging to the relation. So this set B is actually called the codomain of the relation. So now what is range? Now range is different. Actually, set B you cannot call as range, because now we are having an additional element 9, and you know that 9 is not involved in the relation. So this set B is called the codomain, and only the elements which satisfy the relation. So if you see, from the set B we have the elements 5, 6 and 7 in the relation. So the set containing these elements 5, 6, 7, this set is called the range. So always remember, if you are having a relation between two sets A and B, set A is the domain and set B is the codomain. And in the relation, all the images, that means all the y values, if you are taking those elements and creating a set, then that set is known as the range. Now let's say all the y values are included, all the y values in the codomain are included in the relation. So in that case, the range will be equal to the codomain. So only if all the elements from the codomain are involved in the relation, the range will be equal to the codomain. So in general, if you want to write a connection, you can write R is a subset of the codomain. By R, I mean range. So range is a subset of the codomain because all the elements of the codomain need not be involved in the ordered pairs of the relation. Now we have to learn the types of relations. Now, before going into the main types, we have some trivial relations. So the first trivial relation is empty relations. Now, empty relation, as the name suggests, if there is no element in the relation, then it is known as an empty relation. So if the relation is a null set, then it is known as an empty relation. What is universal relation? Universal relation is the next type of trivial relation. Universal relation means if the relation is equal to the Cartesian product. I had told you in the beginning, the range is always a subset, or it can also be equal to the Cartesian product. So if it is equal to the Cartesian product, then in that case the relation is a universal relation. And if there are no elements in the relation, that means if it is a null set or an empty set, then that relation is an empty relation, or you can even say void relation. Void relation. And we also have identity relation. Now, identity relation I will explain when we are discussing the types of relations in detail. So now these are the two trivial relations, that is empty and universal relation. Now we need to go into the major types of the relations. The first one is reflexive relation. Now what do you mean by reflexive relation? Reflexive relation means if all the elements. Now when I'm discussing the types of relations, I am going to consider a relation on a particular set. So that means if I say a relation on a set, it means it is the Cartesian product of the same set. So when I'm explaining the types of relations, I'm going to explain with the help of a relation on a set, like a set A. So now when I say relation on E, it means the relation is from set A to set A. That is the meaning. I hope it is clear. So we are going to consider a relation which is having the domain and the codomain as the same set. You know that when I specify relation on A, it means the relation is from A to A. That is also something which you have learnt in grade 11. So first let's consider reflexive relation. Now when I am considering A and A, the ordered pairs will have the elements which are belonging to the set A. For example, if there is a set A having the elements 1, 2, 3, 4, 5, then all the pre-images as well as the images will belong to the set A. So there won't be any element which is not belonging to A. Now if in a relation the ordered pairs are having the same pre-image and image, that means if the x value and the y value are the same, like for example 1 comma 1 or 2 comma 2 or 3 comma 3, 4 comma 4, 5 comma 5. In these examples, all the x values, that is the pre-image and the image, is the same. So these are the elements which satisfy the reflexive condition, and if in a relation these elements are present, then it is known as a reflexive relation. So one thing which you need to remember is there can be elements in addition to the reflexive elements. These are the elements which are satisfying the reflexivity. But there can be other elements also in the relation. However, these 5 elements which are satisfying the reflexivity condition must be present in the relation if you want to call it as a reflexive relation. So, for example, if I'm having a relation 1 1, 1 2, 2 2, 2 4, 3 3, 5 5. Now, is this a reflexive relation? No, it is not a reflexive relation. Why? Because in the set A you have the element 4. So the ordered pair satisfying the reflexive condition for the element 4 is 4 comma 4, and this ordered pair 4 comma 4 is not present in the relation. So as a result, the relation is not reflexive. Now let's say I am going to add 4 comma 4 also in this relation. Then is it reflexive? Yes, it is reflexive. So I hope now it is clear what I was explaining before. In this case, 1 1, 2 2, 3 3, 4 4 and 5 5 are present, but in addition to that you also have 1 comma 2 and 2 comma 4. These two elements are not satisfying the reflexive condition, but since all the reflexive ordered pairs are present, this is still considered as a reflexive relation. So if you are adding any other element in addition to the reflexive elements, it will not cause any change to the reflexive relation. Now, if there is a relation which is having only 1 1, 2 2, 3 3, 4 4 and 5 comma 5, then this particular relation is called an identity relation. It is a reflexive relation. Yes, it is a reflexive relation, but if in the reflexive relation there is no other element other than the reflexive elements, there is no other ordered pair, then those relations are called identity relations. So all identity relations are reflexive, but not all reflexive relations are identity relations. This is very important for assertion reasoning. The second type of relations is symmetric relations. Now, what do you mean by symmetric relations? Now, let's say I am having a relation 1 comma 2, 2 comma 2, 2 comma 1, 3 comma 4, 4 comma 3. Let's say this relation is from A to A, and the set A is remaining the same as the previous case. Now, when I say symmetric, it means if there is a particular ordered pair, the opposite or the y value and the x value must be interchanged, and that particular ordered pair should also be present in the relation if it is symmetric. So what do I mean by that? let's say I am going to consider this ordered pair 1, comma 2. 1, comma 2 belongs to the relation. Now, what is the y value? Y value is 2 and x value is 1. If I am interchanging the x and y value, what is the ordered pair 2, comma 1? So this particular ordered pair is known as the symmetric pair of 1, comma 2. 2, comma 1 is the symmetric pair of 1, comma 2. So this ordered pair should also be present in this relation R if it is symmetry. And yes, you can very well see that 2, 1 is also there in the relation, so it is symmetric. But please note, this condition should satisfy for all the elements in the relation. So first we have satisfied 1, comma 2 and 2, comma 1 is done. 2, comma 2, you know that 2, comma 2 is an element which is having the reflexive condition. So of course, if you are looking at the symmetric pair of 2, comma 2, it is 2, comma 2 itself. So it is not a problem. The symmetric condition is satisfied. After that, you have 3, comma 4. The symmetric pair of 3, comma 4 is 4, comma 3. So you are interchanging the x and y value. And yes, you can see 4, 3 is also present. So this is also present in the relation. So since all the symmetric pairs for all the elements are present, this relation R, which I have written here, is a symmetric relation. The third one is transitive relation. This is little tricky, but I hope you will understand it once I explain. So what do you mean by transitive relation? Transitive relation means, let's say I am going to consider a relation to explain this. 1, comma 2, 2, comma 3, 3, comma 4, 1, comma 2. Now, I am going to say that this relation is not transitive. Or, sorry, not 1, comma 2. I already wrote 1, comma 2. You can change it to 1, comma 3. So, I am going to say that this relation is not transitive. So now think about it and see, why do you think this relation is not transitive? You can pause the video and think why this relation is not transitive by looking at the elements. So now let me tell you why this relation is not transitive. So I will explain what is transitivity and then you will understand why this is not transitive. If there are two elements A, comma B and B, comma C in a particular relation, that means if one of the image values acts as the pre-image in another ordered pair, then the ordered pair connecting the remaining numbers or the remaining elements, that ordered pair should also exist. This is known as the transitive pair of AB and BC. So now if there is a number which is acting as a pre-image and an image, then you have to connect the pre-image of the element where it is acting as an image and the image of the element where the number is acting as a pre-image, and you will be getting an ordered pair A, comma C. This ordered pair should exist in this relation if you want to call it, or if you want to consider it to be transitive. So here if you see, there is an element 2. The element 2 is an image in this particular ordered pair. There is another ordered pair 2 comma 3. So here 2 is acting as an image. So you have to join the pre-image of this ordered pair and the image of this ordered pair, and you will be getting the ordered pair 1 3. So this ordered pair must exist in the relation if it is transitive, and yes, 1 3 belongs to the relation. Next, we have 2 comma 3 and 3 comma 4. Now 3 is acting as an image here, and it is acting as a pre-image here. So you have to connect the remaining numbers and get an ordered pair 2 comma 4. And as you can see, 2 comma 4 is not there in this relation. That is the reason I said this relation is not transitive. Now, let's look at another condition. Now, you have to satisfy this condition for all the possible ordered pairs. So, let's look at this ordered pair 1, 3. Now here the image is 3 in this ordered pair as well. So if you see, I can even connect 1 and 4 and make an ordered pair 1 comma 4. So this 1 comma 4 should also exist if you want this relation to be transitive. So you have to consider all the possible cases. So if you are only including 1 3 and 2 4, it is not transitive because the number 3 is acting as an image in this ordered pair and even in this ordered pair. So you need to satisfy all the possible conditions. Now, if there is a relation which is satisfying reflexivity, symmetricity as well as transitivity, then that relation is known as an equivalence relation. It is known as an equivalence relation. So I hope this is clear to you. Now I will give an example of an equivalence relation. So let's say there is a relation, there's a set A having the elements 1, 2, 3, and I am considering a relation from A to A. 1, 1, 2, 2, 3, 3. So first I have satisfied the reflexive condition. Next I am going to create an ordered pair 1 2 and 2 1. So now 1 2 and 2 1, yes, the symmetricity is also satisfied. And you know all the reflexive elements will satisfy the symmetric condition. Then if you see, 2 acts as an image in this ordered pair and as a pre-image in this ordered pair. So you need to connect these two elements, and as you can see, 1 1 already exists. So the transitivity is also satisfied. So this is an equivalence relation. There are many equivalence relations that you can make. You can connect any element of your choice. Now in this case, I have created the ordered pair 1 2 and I have satisfied all the three conditions. But if you are connecting 2 3 or 1 3 or 3 1, 2 1, there are endless possibilities. So you can connect them, and also you can connect more than once. So you can even write 1 2 and 2 3 and then try to satisfy all the conditions. So that is up to you, and the number of equivalence relations is endless. You can create as many equivalence relations as you want, but of course there is a fixed number of equivalence relations for a specific number of elements, so that I will be explaining now. So there are certain formulae which you need to remember in the relations topic. So the first one is, what are the number of relations possible? Let's say I am considering a relation from the set A to the set B. And let's say the cardinality of A is M and the cardinality of B is N. Then the number of relations from A to B will be 2 raised to M into N, 2 raised to Mn. This is something which you have learnt in grade 11. Let's say I am considering the number of relations on A. That means the number of relations from A to A. Then the number will be 2 raised to M square. And the number of relations from B to B will be 2 raised to N square. Then what are the number of reflexive relations? Number of reflexive relations. If you are talking about the number of reflexive relations from A to A, then it will be 2 raised to M into M minus 1. And the number of symmetric relations will be 2 raised to M into M plus 1 by 2. 2 raised to M into M plus 1 by 2. Then number of reflexive and symmetric relations. Number of reflexive and symmetric relations will be 2 raised to M into M minus 1 by 2. Then we have to learn number of transitive relations. Now for transitive relations there is no formula, but you have to remember the number of transitive relations possible for 0, 1 and 2, because that will help you for MCQs. So let's say there are 0 elements, 1 element and 2 elements in the set A, or whatever set you're considering. Then if there is a relation, if you're trying to make relations using that set, then the number of transitive relations will be 1, 2, 13. So for 0 elements, you can create 1 transitive relation. For 1 element, you can create 2 transitive relations. And for 2 elements, you can create 13 transitive relations. And if you are having 3 elements, you can create 17. This is something additional. This is not required. Even 2 is not actually required, but 0 and 1 are very important. 2 you can learn additionally, and 3 is something which is not required. Then 7th one is the number of equivalence relations. Number of equivalence relations. So what are the number of equivalence relations possible? So if there is 1 element, then you can have 1 equivalence relation. If there are 2 elements, you can have 2 equivalence relations. If there are 3 elements, you can have 5 equivalence relations. If there are 4 elements, you can have 15 equivalence relations. If there are 5 elements, you can have 52 equivalence relations. So how did I get all this? In order to do this, you need to use the concept of bell triangle. Now this concept is very simple. So what we need to do is, the last element in the row you have to bring down to the first element of the next row. And then you need to add the element above it, and you have to write that as the next element of the row. So let's start with 1. So if there is 1 element, 2 element, 3 element, 4 element, 5 element is the condition. So now first for 1 element it is 1. For 2 I am going to bring 1 down, then I am going to add 1 plus 1. 1 plus 1 is 2. So I am going to write 2. Then the last element of this row is 2. So I am going to bring this 2 down to the third row. Then I will add 2 plus 1. 2 plus 1 is 3. So I will write 3. Then 3 plus 2. 2 is the element above it. So 3 plus 2, when I add, I get 5. And above 5 there is no element. So I will write 5 in the next row, because 5 is the last element. I told you the last element of each row will be the first element of the next row. Then I have to add all the elements likewise. So I will add 5 plus 2. 5 plus 2 is 7. Then 7 plus 3 is 10. And 10 plus 5 is 15. And now 15 is the last element. So I will bring 15 down. Then 15 plus 5 is 20. 20 plus 7 is 27. 27 plus 10 is 37. And 37 plus 15 will be 52. So now all the last elements, if you are taking the last elements, the last element will be the number of equivalence relations possible. So that is how I got 1, 2, 5, 15 and 52 for these numbers. You can try and do the bell triangle rule for numbers 6, 7, 8, 9 and 10. You can do it in your free time, and that will be an additional extended learning for you. So now we have to discuss something which is known as equivalence class. So what do you mean by equivalence class? Now let's say I am considering a relation. I am considering this particular relation that I have written here: 1, 1, 2, 2, 3, 3, 1, 2 and 2, 1. And let's say I am going to add a few more elements: 2, 3 and 3, 2, and even 1, 3 should be added. So now if you see, this is also a reflexive relation. Sorry, equivalence relation. Now this is an equivalence relation. It is having 8 elements. Now if I want to create a connection, or if I want to create a relation which satisfies a particular condition or a particular element, then that is known as equivalence class. So let's say I am writing equivalence class of 2, 3. 2, 3. So now if you see 2, 3, what is the relation between 2 and 3? You know that 3 is 2 plus 1. So if I am writing it in general terms, the equivalence class of an ordered pair AB, if you're writing, then there will be some relation between B and A. So if I'm considering this particular example, then I will write B is equal to A plus 1. This is the condition which the element 2, 3 satisfies, isn't it? So now this particular relation B is equal to A plus 1. It is a linear relation, and we will be seeing in this equivalence relation all the elements which satisfy this condition. And all these elements will be written in a relation, and that is called the equivalence class of 2, 3. So now the condition is b is equal to a plus 1. That means b is 1 greater than a. So now 1 comma 2 is there in this relation, and as you know 2 is 1 plus 1, so it is satisfying the condition. Same way 2 3. Now 2 3 we have already written. We are trying to find the equivalence class of 2 3, but you can include the same element 2 comma 3 as well in the equivalence class relation. So in this case 2 comma 3 also satisfies. Now, after that, the other possibility could be 3 comma 4, but as you can see in the set A the element 4 is not there, so there is no other element which satisfies this condition. So in this particular example the equivalence class of the element 2 3 will be set 2 comma 3 and 1 comma 2. This is known as the equivalence class. So basically we need to see the relation between the image and pre-image of the ordered pair, and all the elements in the relation which satisfy that particular condition you need to include in a separate set, and that set of all the elements satisfying the condition is known as equivalence class. So this is something which you need to work on, because even in the questions they will be asking at the end to find the equivalence class of a particular element. So that is all about equivalence class, and with that we are done with this video. We have to do questions on all these topics. So first I am only explaining the topics. So I will, in the next video I will explain functions, and after that we will discuss questions from this chapter. So first I'm explaining the topics, and then later we will do questions from all the topics, and that will be included in a separate video. So if you have any doubts regarding any of these topics discussed in this video, please feel free to share it in the comment section, and I will surely read your comment and clarify your doubts. So thank you everyone, and if you want me to explain any other topic from any other subject, please let me know in the comments, and I will surely try to film that video as well. So thank you everyone, stay tuned for my next video, and all the best for your academics. So see you everyone, have a good day, bye.